After last video about how Masato found the HTML sanitizer bypass, I thought we could talk a bit more about fuzzing, because fuzzing is actually a typical technique to do XSS and weird browser research. Luckily, Gareth recently shared this tweet with a new interesting Firefox parsing issue. So let's first explore what this tweet is about, and then how did he find it? So what's special about it? Of course, we have again a weird parsing thing. Imagine you would implement an HTML parser to sanitize HTML on the server. And so at some point you have to implement HTML comments. So in order to do this correctly, you will look into the HTML specification and try to follow the rules. Comments must have the following format. First, it starts with the string open angle bracket exclamation mark dash dash. Then comes optionally the comment text with the additional restriction that the text must not start with the string closing angle bracket, nor start with the string dash closing angle bracket, nor contain those strings blah blah or blah, nor end with this string blah. And then the end of the comment is this string dash dash closing angle bracket. Okay, but what do you do when you encounter one of these strings you are not allowed to? This one would be the start of a comment. Do you then nest comments, meaning you need two closing tags, or do you ignore it? What do you do? The second one is clearly just the closing one, so parsing that is fine. But what about the dash dash exclamation mark closing bracket? This is not defined to be the end of a comment, however, you will find that this is actually typically interpreted as a closing comment in the browser. So if you would implement a parser that ignores the exclamation mark version, then you could use this XSS vector to bypass the sanitizer. Because on your server you would ignore this one and the whole thing would be a safe HTML comment. However, when you actually let the browser render it, it will encounter the dash dash exclamation mark closing angle bracket and end the comment, rendering the script tag and triggering the XSS. But let's say you were smart. You tested your parser and the browser parser, and so you also implemented the closing comment. Which means your HTML sanitizer parser on the server would close the comment here, and then it would find the actual script tag, so it would find the XSS and clean it up or reject the input. But this is where now a researcher like Gareth comes in. As a researcher, you might have exactly the mental thought experiment we just did, but now you try to attack this idea. You see, we don't really have an actual target or implementation, we just wonder if the browser is more permissive in the input to parse, and could we then bypass our theoretically perfect sanitizer? Gareth sent me the snippet what he did. Let's have a look. He creates a div element, then he loops through all numbers from 0 to hex 10FFF, and then assigns an HTML string to inner HTML. The HTML string he constructs is exactly what we just explored. We have an open comment, then comes the closing comment with exclamation mark. However, between the exclamation mark and the closing angle bracket, you can find a string from code point, which takes the for loop I. So this dynamically creates single characters from the current number. So it creates any ASCII characters as well as Unicode characters. After that, we have an image tag. So basically, if the character we have created makes the closing comment invalid, then the image tag would be inside an HTML comment closed back here. But if there are characters that are allowed to appear between the exclamation mark and the closing bracket, then we would end the comment and the image tag would become a real free HTML element. And then we would find that with the query selector. So in that case, we add the character to the log. Let's copy it to Chrome and let it run. It goes pretty fast and it finds only a single character. And if we look at what this character is, it's the closing bracket. So no surprise. This fuzzing didn't find anything. Our HTML sanitizer would be safe for Chrome. But then Gareth also tried the same on Firefox. And there we find a few characters that are allowed to appear inside the end comment. It turns out that new lines are allowed. Why? No clue why Firefox parses this so weird, and interestingly it only works with the exclamation mark version, not the plain one without. But this means we could bypass our server sanitizer with the tweet from Gareth. Simply add some new lines here. Our sanitizer would start parsing, find the start of a comment, continue, this looks all safe, so the potential XSS is safe inside of the HTML comment. However, if rendered by Firefox, the XSS will trigger because Firefox seems to ignore the new lines in between. Pretty simple, right? You just have to come up with the test and then fuzz or enumerate possibilities. Let's do another example. Have you ever wondered what kind of characters or bytes are allowed to appear after an attribute before the equal sign? For example, for an on-error event handler, maybe it could help you bypass some kind of sanitizer or web application firewall that looks for on-error equal. So let's write a fuzzer for it. We can just take Gareth's snippet and modify it a bit. We inject the character here and then test if the attribute survived. Run it. And apparently the characters with these ASCII or Unicode numbers are valid, including again new lines. Another example. Ever wondered if you can have some kind of weird characters between the open bracket and the tag name? That would be a crazy bypass for a lot of WAFs, right? Well, let's try it. Chrome and Firefox, but nope. We only find character 60, which is the opening angle bracket. So of course this is still a valid image tag. We didn't find any other possible character. And do you realize what we just did? We posed a research question and just went out and explored it. And by doing this a lot and taking a hot shower and getting new ideas what to test, it can be quite fun to explore what is possible or not. Try it yourself. This is what a security professional would do if they encounter a new filter and try to bypass it. And people like Masato and Gareth know a lot of these weird cases. But of course they don't know or remember all, but they know exactly what to fuzz and how to fuzz in a case they look for something in particular. Actually, Gareth had developed several years ago a whole distributed fuzzing platform for exactly this kind of research called Shazzer. The idea is that anybody can help fuzzing with different browsers and versions. Login or registration is broken, it's quite old at this point. But you can still click around and look at the kind of test cases they were interested in and what they were fuzzing for. InsertScript, his name is Alex, is the top fuzzer and used it more than Gareth. So let's have a look at what he was fuzzing. This test case caught my eye. It's called LT less than eating char, and we can have a look at the fuzz vector. So he was wondering, are there characters that you can place in front of a greater than closing angle bracket, and does it eat it? Yaha, InsertScript obviously has failed math in school, called this greater than sign a less than sign, but it's fine, he's a noob. So he was wondering, is there any character that could be placed there that causes the browser HTML parser to ignore that the tag is closing there? That would be crazy because then suddenly the whole thing would be the tag. In that case, the on-error event would execute. So let's hit fuzz and fuzz this in Chrome. It tests different char sets and different characters in parallel on multiple iframes. It takes a while. And it will also not find anything on Chrome. But we can see the past results here. And apparently on a certain Internet Explorer 10 version, it found several characters where it actually worked. I asked Alex about it and he told me that this was indeed a bug in the Internet Explorer. He found a browser bug, a parsing bug. He also added that it was more luck than judgment, but I disagree. He might have thought he wouldn't find anything, but he did fuzz for it. So if you ever wondered how weird browser bugs and crazy WAF bypasses are often found and how professional researchers work, this is an example how it can look like.